Hey guys, it's Mark Glenn, the GMAT mentor, here to make the GMAT make sense. So I want to talk about combinatorics today. Combinatorics often throw people off because they look scary, right? And even the word sounds scary. But really, in reality, these aren't as bad as they look. There's a few techniques you can use over and over again to solve these. And we're going to go through this with this problem here, which is not an easy example, but it is one I think that illustrates this well. So Alejandra is choosing 3 marbles from a box. I'll simplify it a little bit, just summarize it here. So 3 marbles from a box with B blue and R red marbles, okay? And we know that the number of ways to get 1 blue and 2 red is twice the number of ways to get 2 blue and 1 red marble, all right? And then we can see that we're solving for B and R. And if we look at the answer choices, so basically we're solving a B in terms of R and R in terms of B, okay? So that's what we're looking for. It's a little unusual, right? Because we don't have any numbers, right? We don't know how many items there are that we're choosing from. That's the more typical way we would do this. But just because we have variables instead of numbers, it doesn't change the math. We can still use the same sort of techniques that we know. So keep that in mind. Then we also recognize, okay, that there's 2 scenarios here, right? There's the 1 blue, 2 red, and the 2 blue, 1 red. We don't want to try and solve those all at once. Let's do those separately and then combine them. So let's write those out. So we have our 1 blue, 2 red scenario and the 2 blue, 1 red scenario, right? So for that first scenario, now I always recommend writing out the number of slots, right? So we have 3 slots because we have three marbles that are being chosen, okay? And for that first slot, we'll say that's where she wants to draw the blue marble. So since there's B blue marbles, choose B ways of drawing a blue marble, right? So, and similarly for the second slot, R red marbles, so R ways of drawing a red marble in that second slot. But now there's one less red marble left, right? So for that third slot, we have to say R minus 1 ways to draw a red marble there, okay? And then we simply multiply. So B times R minus 1. However, here's where we got to be careful, right? Because this actually represents the number of items, or excuse me, the number of arrangements if order matters, right? So if order matters, you simply multiply. That's called a permutation, right? But in this case, order does not matter, right? Because we don't have to draw the blue marble first. We could draw red, then blue, then red, or we could draw red, red, blue. We could switch the 2 reds around, right? So it doesn't matter what order we draw those marbles in. So really, this is not a permutations problem. This is a combinations problem, okay? Combinations are where order does not matter. When order does not matter, you have to divide out the redundancies. And how do you do that? You simply divide by the number of slots, factorial. Okay, 3 slots, so 3 factorial. And that's it, okay? So that's the process, right? So you always multiply, and if order does not matter, you also divide out redundancies by dividing out slots factorial. Okay, let's look at the second scenario. So kind of a similar setup, right? Again, for the first draw, we know it has to be blue, so B blue marbles, and then now 1 less blue marble for the second draw, so B minus 1 possibilities for the second blue. And then we have 1 red, so R red marbles, so R possibilities for that slot. Again, and now we simply multiply B times B minus 1 times R. Again, order does not matter here. We don't need the 2 blues first, so we must divide by slots factorial, which is 3 factorial. And then now we have our 2 scenarios, right? So now we're in pretty good shape. We know that those are related by the fact that the first scenario is twice the second scenario, right? Twice the number of ways. And now we can have an equation that we can work through. So let's simplify it. Multiply both sides by 3 factorial. Divide both sides by B. Divide both sides by R. Now we have R minus 1 equals 2 times B minus 1. Which we can simplify a little further. R minus 1 equals 2B minus 2. Okay, and now, again, what are we trying to solve for? R and B, right? So easiest to solve for R first. We just add 1 to both sides. So R equals 2B minus 1. But that's the second question, right? So don't bubble in the wrong column here. But that is this second choice here, right? So for the second column. And now we just want to solve for B. So I'll go from here. So if we add 2 to both sides, we have R plus 1 equals 2B. Divide both sides by 2, B equals R plus 1 over 2. So that's the answer to the first question, right? Which is this one here. and we're done. We have both of our solutions. Again, it's a two-part analysis question, so twice as much, I guess, in terms of answer choices, but still the same process you would follow for a quant question. And also remember that again, there's a few things that you just always do for these combinatorics questions. So make sure that if there's multiple scenarios, you do them separately. Okay, write out the slots for each scenario, and then remember to divide by the number of redundancies, the number of slots factorial, if order does not matter. Okay, so again, makes these questions a lot simpler than they first appear, and hopefully that helps the GMAT make sense.